we've been talking about finding limits out numerically and graphically. Now we're going to do finding limits algebraically.
No.
There are some limit rules that you need to have in order to be able to do this. It makes things a lot easier. So, let's say you have two limits, f of x and g of x. So limit x goes to a of f of x, and limit x as it goes to a of g of x. Okay? Here are the rules that go with them. Limit as x goes to a, if you take the limit of the sum, f of x plus g of x, you can split up that sum and find the limits of both of the functions by themselves. The same thing goes with subtraction. So you write the same thing, you can split them up, find out what the limits are, and subtract them. The same rule holds for, let's say you have the whole thing multiplied by a constant. You can pull that constant outside and find the limit of the function, multiply by the constant. And then we have the things that are multiplied and divided. It's the same idea if you have two functions that are multiplied. So maybe like you had two things you had to FOIL. Instead of FOILing them out and then trying to find the limit, you could just take them apart, find the limits, and then multiply the limits. And like I said, the same thing goes for dividing as long as g of x doesn't equal 0, or the limit of g of x doesn't equal 0. If you're taking something to a power, so the limit as x goes to a of f of x to a power, you can take the limit of the whole thing and put that to the power. Same thing with the roots, which should make sense because roots can be written as exponents.
How many are there?
There's just these are the main ones, and then there's like some special rules that just make life easier for you. It would make sense. Just math life. So here are some special rules. If you take the limit of a constant c, you get the constant. If you take the limit as x goes to a of x, you get a, because you just plug in a. If you take the limit as x goes to a of x to the n, you get a to the n, because you can plug in a. And lastly, if you take the limit as x goes to a of the nth root of x, you get the nth root of a. This one is especially important. That one's especially important because we're talking about, like, you can just substitute it in directly. And the other big thing you want to remember here is if you're doing piecewise functions, algebraically what you have to do is evaluate from both sides and see if they match. So that's sort of like what we were just doing. So, I'm going to go through some examples in a minute, but I want